Okay, so guys, today we're going to talk about natural logs. And natural logs are something that was probably used the most in real world as far as logs are concerned. So title your notes, natural logs. And guys, a log is something that has a base of E. And E is kind of like pi. Okay, it's an irrational number that goes on and on. So in this case, it's 2.71828 and so forth, right? And basically, it helps us measure, okay? It helps us measure growth, and they use it for growth and decay. We use it to talk about our finances, okay? Anything that has to do with exponential, right? People use it for that. Also, you might sometimes see it in radioactive things, like if they're doing radioactive material. They want to know, how many years will it take something to decay, or how many years will it take money to grow, right? It measures growth and decay, and there's a relationship between that. So it's used so much in the real world that it has kind of its own value, kind of like pi. And if I ask for something with a log, okay, with a base of E, in other words, a base of 2.7, okay, to 3.32, then the answer is 1.2. And what they've done is we use log base E so much that instead of using it, people just write LN. LN is with a cursive L, and it stands for natural log, okay? But it's backwards, it's log natural, okay? But they use LN instead, right? And then it's gonna be the natural log instead of log base E. So you'll see this written just like this. And what it means is that if you took E, or in other words 2.7, okay, which is here, and you raised it to the 1.2 power, in other words, for example, okay, if you let something grow like 1.2 years or 1.2 days, whatever unit of measure you're using. So if I let something grow 1.2, it would be, okay, 3.32 times bigger. Right, and that's where that number comes from. All right, so what we're going to do is practice writing that. So we're going to write the natural log. Remember, that's the same thing, guys. It's just log base E. Those are the same things. So the natural log of 4, and I told you it equaled 1.39. And I want you to write it in exponential form. Right, if I'm asking you to write something in exponential form, then remember the base of the log is the base of the exponent, right? Of the exponential. What's the base here? The base is E. Okay, not a base 4, not a base 10, it's base E, which means you want base approximately 2.7. So if you want, you can kind of put an imaginary E there until you're used to using it. And it would say, in other words, if you're going to write in exponential form, this is E to the 1.39 equals 4. And you can actually type this into your calculator, okay? There's an E to the X button, okay? And you do the second, okay? And then the LN button, and you'll see the E to the X. And if you type in E, which is actually 2.7, and that X you put 1.39, you'll get 4, all right? Now, number 2, if I told you to write E to the negative 2 equals 0.14 in log form. Okay, in log form. Now this is a base of E. If your base, we're used to seeing bases of 4, bases of 10. And so if it had said something like, if I told you to write 10 to the 3 equals 5 in log form, you would just say, okay, log base 10 to the 5 equals 3, right? Which is not accurate. I was just showing you an example. Okay, here, if I'm going to ask you to put this in log form, you do the same thing. The base through the answer to the exponents. Since the base is E, instead of writing log base E, we're just going to write ln, okay, to the 1.14 equals our answer, negative 2. And that would be that answer. So now, the same exact rules, guys, apply for natural logs as regular logs. The only difference is it's written as ln because the base is 2.7 every single time, okay? So for number 1, if I asked you to find the ln e to the 6th power, I want you to simplify that, right? In other words, find the value. Well, what I'm actually saying, if we would normally set this equal to x and do circle math, the base is not written, but the base is e, isn't it? So if you took all this away and I just asked you, how do I get, if I'm asking you for the log is an exponent, right? So what log gets me from e to the 6? What exponent gets me from e to e to the 6th power? It would be 6, right? If you did circle math, you'll get the same answer. E to the x equals e to the 6th. So x is 6. So when I'm asking you for ln of e, I'm asking you for an exponent. Okay, it's the same as a log. Number 2, if I'm asking you for the natural log of the square root of e, well, first of all, if we're talking about logs, it's easier to deal with exponents, right? So let's do e to the 1/2. I'm going to change that. And if you want to think about this for a second, what exponent, what natural log would get me from e to the 1/2? How am I going to get from e to the 1/2? If you set this equal to x and you did circle math again, e to the x, right, equals e to the 1/2. What exponent gets me from e to the 1/2? Well, it would be 1/2, right? Okay, now let's move to number 3. So now that you're understanding that, what about the natural log of e? What exponent gets me, or what answer is the natural log of e? Well, what's the base of a natural log? The base is e. So what exponent gets me from e to e? 1, right? You guys will notice that anytime you just see the natural log of e, the value is 1. The value of natural log of e is 1 because the exponent to get from e to e is just 1 every time. So anytime you see the natural log of e, the value is just 1. All right, let's look at number 4. So for number 4, if I told you the natural log of 1 over the cube root of e. So what exponent gets me from a base of e to that? Well, I'm not sure. So let's put this with an exponent to make it a little easier. So this is going to be 1 over, and this is the same thing as e to the 1/3 power, correct? And anytime you have an exponent in the denominator, it becomes negative. So this is the same as e to the negative 1/3. Correct? So what is the exponent that gets me from e to the negative 1/3? It would be negative 1/3. Okay, now continue the next video to watch the rest of the lesson.